So in this video we're going to use determinant properties or properties of determinants to simplify the calculation of a determinant. So we want to calculate the determinant of matrix A, and what we want to notice is that in matrix A, column 2 and column 1 are going to be useful to us because if we look at this, we see that 6 is 3 times 2. If we multiply the 3 times 2, we get a 6. And if we multiply negative 1 times 2, we get negative 2. And what this tells us that is if we multiplied negative 2 times column 1 and added it to column 2, replacing column 2 with the result, we would wind up with zeros in both of these positions. And property 3 of properties of determinants says that if we can generate a matrix B from A by adding a multiple of one column to another column, then the determinant of A and the determinant of B are the same. So what we want to do in this instance is take our matrix A and apply elementary row or column operations, as it turns out, to matrix A to introduce zeros into these two positions. So we start with our matrix A, which is 3, negative 1, 2, 6, negative 2, 6, negative 1, 3, negative 4. And this is our matrix A. And what we want to identify is that if we take negative 2 times column 1 plus column 2, replacing column 2 with the result, we'll get 0 in both of these positions. So we wind up with a new matrix, which we'll name B. So we're going to manipulate column 2. That means that column 1 won't change. That means column 3 won't change. But if we do negative 2 times column 1 plus column 2, we get negative 2 times 3 is negative 6. Negative 6 plus 6 is 0. We replace column 2 with the result. Negative 2 times negative 1 is 2. 2 minus 2 is 0. And negative 2 times 2, negative 2 times 2 is 4. Plus 6 is positive 2. So we've applied an elementary row operation or elementary column or row operation, and the one that we've applied, which is corresponds to property 3, identifies that the determinant of the matrix B is exactly the same as the determinant of the matrix A, which means if we want to calculate the determinant of A, it will be sufficient to calculate the determinant of B. And the determinant of B, what we can do is calculate the determinant of B with respect to column 2. So we'll do a column 2 expansion of the determinant calculation. So remember that the determinant, the cofactors, alternate signs starting at positive, negative, positive, negative. So we know we're going to get a negative in our cofactor expansion. And it'll be negative 2 times the element 2. When we're expanding with respect to column 2, we don't need to worry about the first two elements because we'll get 0 times a cofactor matrix plus 0 times a cofactor matrix is just 0. And then it'll be plus minus minus 2 times the minor that goes with row 3 column 2. It'll be the row 3 column 2 minor. And remember, the minor is just the determinant of the matrix we get when we strike out row 3 and column 2. So we take the determinant of the matrix that's left when we strike those out. So we get 3, negative 1, negative 1, 3. And then we can do this calculation. This is equal to negative 2 times the determinant of a 2 by 2 matrix, which we take the product of the main diagonal. 3 times 3 is 9 minus the product of the other diagonal. Negative 1 times negative 1 is positive 1. We get negative 2 times 8. I didn't get my negative sign there. Negative 2 times 8, which is just negative 16. So what you can see is that utilizing determinant properties, we've taken and really simplified the calculation. For the original matrix A, we would have had all three calculations to do because there were no zeros in any row or column. we would have had to have done a maximal quantity of work to do the matrix, or sorry, the determinant calculation.